Now we're going to skip this one till next time. Next time, we're going to revisit the same problem, and we're actually going to come up with an algorithm that will always load the maximum possible weight. All right, but another problem I want to do, and we wanted to give you something two-dimensional, where you have to loop over an array, over a matrix. Okay, so this will involve nested loops. And the particular problem we're giving you here is it's just a black and white image, which in MATLAB is just a matrix of zeros and ones. 0 is black, 1 is white. And what you're going to do is smooth the image by averaging pixels. Okay. So what you're going to do, you're going to go through this matrix and you're going to replace each pixel by the average of itself and all of its nearest neighbors. And that'll just kind of blur out the image. All right, here's how it's going to work. So we give you a matrix of zeros and ones that represents some black and white image. So this would be like an X pattern. First thing you do, you make a copy of it because you don't want to modify the original matrix. Okay, if you make changes to the original matrix, that'll mess up the averaging. So you make a copy and you only make the changes in the copy. All right, now another thing we're going to do, just to simplify it, we're going to stay away from the edges. First and last row and first and last column, because that's just a special case. It makes our code more complicated. So for the purpose of this exercise, we're just going to simplify it. We're going to start at the second row and second column and go to the next to last row and next to last column. Okay. All right, so we're going to start at row 2, column 2. And we're going to pick out the 3 by 3 submatrix around that pixel and take the average. And then replace that element in the copy, not in the original matrix, with that average. All right, so that's the basic idea. Now, how do you get this 3 by 3 submatrix? Just with indexing. Okay, I'll come back later and just kind of sketch out the code for you. But it's just, you don't need to get really complicated with like 4 nested loops or anything. You can pick out this matrix just by indexing. I'll show you that in a minute. All right, so we've averaged the first pixel. Then we go to the next one. And we do the same thing. And again, important, we didn't change the original matrix. Okay, that one is still there. We changed the copy. All right, so we go to row 2, column 3, and we do the same thing. 3 by 3 submatrix, take its average, replace that in the copy with the average. And we go to the next column, do the same thing. And again, we're skipping the last column, so then we go to the next row. Same thing. Next row, same thing. And we're done because we skipped the last row. All right, so that's the basic idea. Now, how does the code work? Actually, I'll just show you here. All right, so we didn't talk last. If you look in the presentation from last time, there were some slides I didn't go through at the end showing nested loops. All right, so this is an example of a nested loop where what we're going to do, first we're going to loop over all rows. So row, let's just say R for row or whatever you want to call it. And again, we're going to start at 2 because we want to avoid the edges. Forget the pen. I just have not learned, just have not become skilled at using that pen yet. I'm going to start at 2. and go up to however many rows there are. I'm going to say, let's say this is a M by N matrix. This will be M minus 1 because we want to skip the edges again. Okay. And how do you get this? You get it from the size function. Use the size function to figure out the number of rows and number of columns. All right, then that's the outer loop. Then within that, you have a nested loop. Where you loop over the columns. And this also goes from 2 to the number of columns minus 1. Okay, so remember the way this works, the inner loop goes through each value for each execution of the outer loop. Okay, so first row is 1, I'm sorry, 2, so we're starting at 2. So row is 2, column goes from 2, 3, 4. And then the outer loop increments, and now row becomes 3, and column again goes 2, 3, 4. Then row becomes 3, and column is 2, 3, 4. All right, so it goes through each column, goes through all columns for each row. Okay, so we're going across each row. And if you reverse the order of the two loops, it would go down columns instead of across rows. All right, now here's the thing that if you learn to use indexing skillfully in MATLAB, it saves you a lot of trouble, because we want to extract a 3x3 submatrix centered on RC. And we don't want to have to do another nested loop. So you just do, what are we calling this matrix? Let's call it, since I used M for the dimension, let's call this matrix, call it I, since it's an image matrix, so we'll call it I. So you take I, right, so we're centered on row R, column C, and we want to go one row to the left, one row up and one row down, one column to the left and one column to the right. So we go R minus 1 to R plus 1, C minus 1 to C plus 1. Okay, that's the submatrix. And that's what we take the average of. Okay, but remember, with a matrix, if you apply the mean function, it does it column by column. We want the mean of the whole matrix, so we do comma all. Okay. I hope that's legible enough that you'll be able to figure it out. And then remember, that goes into the copy. So let's say this was I, and then we copy to maybe call it IC for a copy of I, whatever. Okay, so that means IC of RC is going to be this. All right. So we loop over all rows and columns, but skipping the edges. Look at the submatrix centered on that, the 3x3 submatrix centered on the current pixel. Take its average, and that becomes that pixel in the output matrix. All right, that's pretty much it. You know, all the pieces are here. You just have to put them together now.